Chapter 9, Thermochemistry, Exercise 9.63. A wafer of pure gold is submerged into water in an insulated container. We're given the mass of gold of water. We're given the initial temperatures of gold and water. We're also given the specific heat capacity for gold and for water. What's the question? The final temperature of both substances at thermal equilibrium. That means they reach at the same temperature after some heat flow from, in this case, gold to water, because initially gold has a higher temperature than water. And you can see the final temperature should be greater than 26.7 but lower than 69.6. And also because the specific heat capacity of water is much larger than that for gold. How much larger? Roughly 30 times larger, maybe 30, 31, 32 times larger. This is 4.18. This is 0.128. So big difference. So the final temperature should be much closer to the initial temperature of water. So somewhere, I think, I'm guessing here, maybe 29 degrees Celsius ish. Alright, let's do the calculation. Over here, Q gold plus Q water should be 0. Alright, because together, if we look at gold and water together as the system, this system overall has a 0 Q because the system is insulated. So we have this equation. And also you can tell that this equation is also correct. Q water is simply negative Q gold. This is also correct. Alright, either way we can do the calculation. So I'm gonna get back to my initial equation over here. And Q gold is going to be the mass of gold times the specific heat capacity of gold times the temperature change of gold. Alright, Q water is going to be the mass of water times C sub S of water times delta T of water. So we're just plugging numbers. Q gold, the mass of gold, C sub S of gold, and over here the temperature change. I'm going to use X for the final temperature minus initial temperature. Make sure you use the mass of gold, C sub S of gold, and this is the initial temperature of gold. Over here, X is the final temperature of gold and also final temperature of water. Now Q water, a very large mass, a much larger specific heat capacity. So again, the final temperature will be really close to the initial temperature of water, just a little bit above this. Alright, so we'll see. This X is the final temperature of both gold and water. Alright, we have the equation. I don't think it can be solved this way, but let's try it. Okay. It's alright. We will just rearrange this equation and eventually we'll be able to solve it. Alright, so what we will do is we'll do this multiplication here. So I want to show you step by step. It's 4.0064, and I'm gonna compute this. Oh, 265. So you can see this is for gold, this is for water. So I'm gonna copy this equation here times this plus 265 times this equals 0. Alright, we need to solve this equation. And what we're gonna do is we're gonna multiply this 4.0064 to this, and this. We multiply this, we multiply this. We'll get 4 terms. Alright, 4 terms, 2 of which contain x. The other 2 are just numbers. So I'm gonna rewrite this equation this way. Alright, I just expanded everything here, and now you have 4 terms. 2 terms contain x. The other 2 terms are just numbers. Alright, and now we can combine this two. Okay, equals this number plus this number. Alright, I rearranged this equation to here. This times this go here, this times this go here, and then we have 2 terms that contain x. So now what is x? X is simply this sum, alright, divided by this sum. That's going to be x, right? So we get the final result, 27.3, and indeed it's really close to 26.7. 3 sig figures. Okay, now quickly we'll look at mastering chemistry here. So the equation is this for gold. They have mass of gold, CS of gold, and this is temperature of gold. And for water, you have mass of water, C sub S of water, and the temperature change of water. Alright, you can set it up this way as well. You can see the mass equation is this: Q of gold is negative Q of water. I did it slightly differently. I did Q of gold plus Q of water equals 0.